For step 2C, I'll start with the main function. I'll copy it in from the HTDAP template and edit from there. For this program, our analysis task is to create a pie chart that shows the proportion of BC's population in a given year that is growth due to births, growth due to migration, or pre-existing. Since we want this to work for a given year, we need to add a parameter to our main function. I'll call it year, and it's of type integer. Since our goal is to produce a graph or chart, our output type will be none. Our analysis function will do the plotting, and whenever we have a function that creates a graph or chart, it will show the graph or chart and then return none. So since main returns the value that analyze returns, its return type also needs to be none. I'm going to rename the analyze function to plot population pie chart so that its name implies what it does. It needs the result of read, and it also needs to know the year that is passed to main as input. It needs to know the year for the pie chart that it should produce. I also need to update the purpose. So reads the file from the given file name, and we'll say, and plots a pie chart showing the proportion of BC's population in the given year that is growth due to births or migration or was pre-existing, and returns none. The next thing we need to do is some examples for main. The main function returns none. So our test will not allow us to check whether the pie chart that is produced is what we expect. But the examples are still valuable, as they would allow us to think through how to call the function. They also allow us to see that the code runs without errors, or perhaps that there are errors that we need to fix. Main takes the file name and a year, so I'm going to copy the file name from my test from read since I have them there. I'll do one for test 2. Oops, and I shouldn't have closed that. Main takes 2 inputs, there we go, and our expected output is none. So I'll run these tests. Oops, I have an error, let's see. Oh, plot population pie chart is not defined. So of course I've tried to call a function that doesn't exist yet. Let me go and create the stub for plot population pie chart, and then those tests should run. I can see that my first input is a list of population change, because my first input is the output from read. My second input is a year, and this is going to produce none. I'll copy my purpose from main and have it return none. So now if I run this code, I do expect my test for main to run without errors, now that I have a stub for plot population pie chart. In order to do our plotting, we need to import the PyPlot library from matplotlib. So I'll add that to the top of our cell. Now we can complete the design of plot population pie chart. The next step, as we've done our stub, including signature and purpose, is some examples. Similarly to main, it's useful to write these examples to make sure that we can call our function with appropriate input and that it runs without errors. But these examples will not help us figure out if the pie chart that we produce looks like we expect it to look. We need to examine that visually. We can look at our example that we drew for step 1C, the planning step, as a reminder of what we're wanting this to look like. But let's write some expects. I'm going to copy these as a start. The first input is a list of population change, so I will borrow these two. We know the second input is a year, which we already had. Remember to update the function that we're calling. And the expected output is none. So I expect these tests to run without errors. Now, as we can see, all of our tests are passing, but we know we have not yet finished implementing the function. The tests are just passing because they're expecting none, and our stub always returns none. So we know we still have to finish writing this function. For our next step, we'll comment out the body of the stub, and now we're at the template phase. For visualization functions, we don't have a template in the same way that we do for other functions. Instead, I often copy the code from a worked example and make edits as necessary. So I'll paste in the code from the work example, and we see that it says template based on visualization. That's because we're basing this on other visualizations that we've created. One thing I notice right away is that it says plt.py and plt.show. That's an abbreviation for PyPlot that we sometimes use. But if we scroll up, I can see that in this example, I used the full word PyPlot. So I'm going to change those two. So let's complete this function design. I see two lines of code, one to show the plot, and the one above pyplot.py to actually create the pie graph. We can see that we need to specify the percentages, which is given as the variable fractions. Now remember that this was copied from the worked example, so fractions does not exist in our program yet. Whether we want to explode the pieces, I can explain what that means in a minute, what the labels are, how to format the percentage, and whether we or not we want there to be a shadow. So let's think about what we need to calculate here. We need to get the fractions, and that's the percentages or the proportions for each slice of the pie. So for us, I'll call this proportions because that's what I've been calling it throughout this example. And that is a variable that we will need to set. It's going to be a list, and it's going to be a list of length 3 because we want to have 3 slices. The slice for the pre-existing population, the slice for the births, and the slice for the migration. Explode is going to be a list of the same length. We'll fill it in once we finish the proportions. And in explode, we'll use numbers to specify whether we want the pie chart slices to explode a little bit out of the circle or not. Labels is also going to be a list of length 3. Oops, forgot to put the 3 there. Where the labels have to be in the same order as the proportions. So if the first entry in the proportions list is the percent due to births, then I would want my first entry in the labels list to be the label for that, or births. So they're going to be in the same order through the proportions and through the labels. How to format the percentage we'll leave for now, but we'll talk about that more in a little bit. So now we need to think about how to get these proportions. Given the year, I need to find the proportion of total population for births, the proportion for migration, and then the pre-existing, which is the remainder. The first two in particular sound like subtasks. So I will need to design two helper functions to get me the percentage for births and the percentage for migration. Maybe I'll say proportion. So I'm wishing that I had a function called getBirthsProportion that takes the list of population change and the year and will return the proportion of population in the given year that were due to births. I'll do something similar for migration. And then the remainder, or maybe I'll call it pre-existing, is the entire population, which is 100%, minus these two. Now I don't have getBirthsProportion or getMigrationProportion designed yet. They don't exist. So if I were to run this code, I would get an error. I'm going to pause now, complete these designs, and then resume. I won't do these designs as part of this video because you have the tools to do these function designs based on what you've already learned in this course. Now I've designed all of the helpers that we need. So getBirthsProportion, getMigrationProportion, and the helpers that I need when I was designing them. I'll quickly scroll down and show you these helpers. getBirthsProportion calls a helper to check if the population change, as we loop through the list of population change, is of the year that we're looking for. And if so, it returns the birth percentages from that population change. You can see that in this function design and in getMigrationProportion, I had to decide what to do if the year was not represented in the list, and I chose to return 0. getMigrationProportion also calls the correct year helper, and it calls and returns the value from migration percentage if it finds the year that it's looking for. In both birth percentage and migration percentage, I did the division, so births over total population or migration over total population, multiplied by 100 to get it into a percentage, the way that Matplotlib expects it, and then rounded to 3 decimal places. Now that we've seen our complete function designs, let's go back up and finish our plot pie chart function. Now our variables proportion births, proportion migration, and pre-existing contain the percentages that we want to put in our pie chart. So I'll put those into this list, proportions, that I pass to pyplot.py. Next I'll do the labels, and I need to make sure that the labels are in the same order. So because my percentages, I put births first, then migration, and then pre-existing population before, and I would like this to include the actual year. So I'll use the year that we were given as input and convert it to a string. The next list that I need to complete is this explode list. And this will specify whether I want the slices of my pie chart to explode out of the pie chart a little bit. Since I expect my births and migration to be a small percentage of the overall population, and I want to make them a little bit more visually apparent, I will add in some values for explode for those two, and not explode the main pre-existing population part. You can play around with those values. Higher numbers make the slices explode out even further. So now let's run our code and see what we get. So if I scroll down, I can see these pie charts that are produced from my examples. If I keep going, I do have a call to main, which shows me based on my full set of information and asking for the pie chart for 2011 what I get. I notice that I have not yet set a title. So I'm going to scroll back up and add a title. I also think I want to make these a little bit bigger. They're somewhat small. To set the size, I'm going to use subplots and fig size. Now I wouldn't expect you to know how to do something like set the size. You could read the Matplotlib documentation, and you can certainly ask questions. We're happy to help you try to figure out how to make changes like this. For the title, I'm going to have the title be BC's population in, and then I want to add the year. So let's run this again. There we go. So now my pie charts are a little bit bigger. Makes it a little bit easier to read. Scroll down and see our main one. Now I can really see the percentages. I can see my titles for each of the slices and for the chart overall. And I can see that migration and births are both popped out a little bit. They're both exploded. So what we've done today is created a pie chart visualization in a How to Design Analysis program. And this is similar for what you'll need to do for your final project.